Hello, everyone, and thanks for joining us today for this presentation. I'm happy to be here today with Matt and Dale to talk about the ClickHouse and HEX integrations. We put together this team of presenters. We have Matt first. Matt, you want to say some words?
Yeah, pleasure to be here. Excited to talk about the power of combining HEX with ClickHouse. Dale put together an awesome demo. Excited to talk more about it.
Thanks, Matt. Dale is our product architect and engineer at ClickHouse. He'll be the one leading the demo section where he'll show basically live this very powerful integration screen, integration scenario. And then on my end, I'm in charge of integrations here at ClickHouse. And my job is basically to make sure that we have a comprehensive set of integrations and that these experiences are well curated and adapted to the different use cases people use ClickHouse for. So this is our agenda for today. We'll do a quick round of introductions on both technologies, starting with ClickHouse and then HEX to make sure that everyone is on the same level of knowledge about both. We'll pause a little bit talking about why this integration matter, but we'll leave most of the time for the actual demonstration, building a real-time analytics app called ClickHub that is actually quite exciting. So in few words, what is ClickHouse? ClickHouse is, first of all, a column-oriented database, meaning that it has the capacity to process very large amounts of data. Thanks to the way it stores this data, it can then propose very powerful aggregations on top of it. By orienting the data towards columns, it can index it and leverage very powerful locality effects, meaning that it can basically compress data with huge efficiency, sort this data, and answer queries in the millisecond scale. It's also a very successful open source project, widely adopted. And now it's also a cloud service named ClickHouse Cloud, where you can run all of this experience with zero setup. It's suitable for any real-time analytics use case, but also for observability, for logging, anything that involves usually large amounts of data and requirement for a real-time query time. It's also a very powerful open source ecosystem around the main open source project, which means that we have literally thousands of integrations for ClickHouse, ranging from language clients to data ingestions to SQL clients, as well as visualization solutions. And in that visualization solution, basically there's a tool for any use case. People tend to use things like Grafana, Superset, Metabase, but also some dedicated software that can be adapted to the data science use case. For example, HEX is a very powerful one. And we've been quite happy working with it, preparing this demo. So we thought it's worth sharing with the rest of the world. And it's worth also spending some time with Matt here talking about this integration scheme. So maybe, Matt, you can tell us more about HEX.
Yeah, so HEX is a collaborative platform for analytics and data science. It lets you do querying and then combine SQL with Python or R. So you can kind of have a very in-depth analytics workflow in one tool versus having to kind of move your queries into separate tools. And then we have no-code visualization built in, which makes that very easy. And the big power that HEX has that is going to be shown off in the demo is that you can go with this kind of deep notebook UI style analysis, but then select pieces from that analysis and turn it into an app. So you can add in controls so that the whole app becomes interactive. So you can kind of capture the whole analytics process in one tool versus having to kind of do an analysis here and then build a dashboard there. We're very excited to integrate with ClickHouse. It makes the apps run very, very fast on large amounts of data. And that's what Dale is going to show off in more detail. But it works just like you would connect any data source to a typical data tool where you can query it and then again use whatever language you like to further manipulate that data and then present it to the rest of your team.
Thanks. So I think, yeah, what's really interesting is that combined with query times from ClickHouse, answering milliseconds, it allows basically building very responsive applications and then iterating on that process very quickly and exposing them to the rest of the world, like we will see in the demo in few seconds. So without further ado, we'll leave it to Dale for building ClickHub live in a demo environment.
So I'm going to give a quick demonstration of how you can use HEX with ClickHouse and bring real-time analytics on petabyte datasets to your notebooks. In this case, I'm going to build a demo application, a proof of concept, which we've called ClickHub. And this is really how I personally use HEX a lot, is I use it to try out an application and a few ideas and build some visualizations, lay them out, and then maybe I'll go and take those ideas and build a production application. But in terms of the barrier to entry, this is a lot lower and we can get something pretty impressive in just a few minutes. So in our case, I set about with the intention of building a better GitHub Analytics. So we've probably all gone through the experience whereby we hear about a new open source project, maybe at a conference or in a video, and we head over to the repo and we can see some stars and the contributors, and maybe we can see the commit frequency as well. But generally, we're kind of left wanting a little bit more. We can't get deep analytics on who's contributing to which parts of the code, for example. It requires us to navigate the source. Unfortunately, this is not something that GitHub has invested a huge amount of engineering in, and we're often just wanting a little bit more than what we're given. So let's say we wanted to build a better GitHub Analytics. What data sets would we need for this? Well, this demo is really a story of two data sets. So the first is the GitHub Events, which is available through the GitHub API, and this is available. You can get the latest commits, the latest stars, issues, forks for every single repository on GitHub, and that's available as a stream. You need to be sensitive to its quotas, but it's about 6.2 billion events as of 2011, and you can get 1-minute updates. So that's just a simple case of polling and respecting those quotas. And that's a rich data set for an overview of all the GitHub repositories. Now also, if we wanted to delve a bit deeper, we would probably want all of the commit history for all of those repos. That takes a little bit more work, and I've actually blogged about how we achieve this. But ideally, we would have a row in ClickHouse for every line change for the top 100,000 repositories on GitHub. And that would be every single commit. So every single time a line changes in a commit, we would get a row entry. And that would allow us to do a really deep analysis of a repository. So that's about 15 terabytes cloned if I cloned all those repos and I cloned them to just a disk in AWS. And it's about 50 billion rows in ClickHouse. And it compresses really well, actually. So it compresses about 15 to 20 times. So and ClickHouse is great for that as a column-oriented store. And we get about 1 terabyte of compressed data in ClickHouse. And then we need to keep that data up to date. And to actually generate those rows, I use a tool called Git Import, which is distributed with ClickHouse and available for download. So if you install ClickHouse, that tool's available to use. And if you want to read, there's the blog post here, which you can take and read about how we did it. Just a quick overview of that. That commit history we generated by basically just building a worker pool. So we add all the repos to a queue, and then workers take those off, clone them onto a shared disk, and then those workers are rescheduled, or jobs are put back onto that queue. And if the repo has already been cloned, we just do a git pull, regenerate the delta, and insert that into GitHub. So we get 3 tables: line changes, file changes, and commits, where line changes is the deepest level of granularity, and commits is just a row for every commit, versus line changes, whereby it's a row for every single line change. I'm not going to look too much into this data because this demo is really about the integration with HEX and ClickHouse. But if you're interested, as I said, you can go and look at the blog post on the previous slide. So let's actually have a look at this. So I'm going to build I'm going to start building this. I'm not going to build the entire application. I'm just going to give people a feel for what it would be like if you wanted to build an application like this. So the first thing that we need to do is we need to connect HEX to ClickHouse. Now, what you're seeing here is effectively just the landing page. So I've started a new project in HEX. I have actually already connected to ClickHouse already, but I'm just going to go through the mechanics of it. So the data source is on the top left, and then create new data source. I can select ClickHouse from the list, and then I'm just going to call this ClickHouse. I call it ClickHouse Demo 2. I need to put in the host name and the port. Port is 8443, so we use the HTTP port. The password for this, and this is a ClickHouse cloud cluster, so the default password, enable SSL, and that's pretty much it. And we just create that connection. So it's really as simple as that. I'm not going to save that. And now we're connected we're now connected HEX to ClickHouse. So we could now use that connection in our notebook. Now, if we imagine our user experience, maybe our user comes to our application and they need to enter the name of a technology or a repository. That could probably be, in an ideal world, that would be an auto-completing drop-down. They select that and the analytics are populated. Now that doesn't exist as a component in HEX, so we're going to just imitate it a little bit, which is fine for our proof of concept and enough for us to go to our manager and say, look, I want to build this application that I've built in a few minutes in HEX. So we're going to imitate it with a text entry box where we put the name of the technology and all the matching repositories to that name. So it could be ClickHouse, it could be Spark, would be populated in a drop-down, and then we select the repository from that drop-down. So we'll just have a two-step process instead of one. Now, what you see here is a new project canvas. So there's nothing here at the moment, and I need to start adding components. When I add my first component, which will be this text entry box for the user, I just go to Inputs, Text Entry. It immediately gives my project a title. I'm going to call my project ClickHub. I'm a pun on ClickHouse and GitHub, and maybe we call it maybe the next, no, just to be a bit bolder, better than GitHub Analytics. And I should say that we have two views here. We have the logic view where we construct our components, and then the application view where we actually see the result of how they will be rendered. So this is our text entry box. Let's give this a title. Let's say repository search. Now the value of this, which let's just work with ClickHouse as a value that the user is searching for, will be put into a data frame called input1_1, which we can then use in subsequent when we're building subsequent components. So we can use that to make our application dynamic. I'm actually going to rename that, call it Yuko search. But if I go over to my application view now, we now see that it's been populated. And the user could, in this application view, change this if they wanted to. So the objective would be that this value that they put in here is then used to go and grab a list of repositories that are like this name, and then populate our dropdown. And for that, I need to query ClickHouse. So I need a SQL query. So I go to SQL, and I'll need to select the connection. And this is really simple. And this is this templating language that I'm using here. So the value of this data frame, which is just a single value, is templated into this query. And we're just doing an I-like query where we're using a string concatenation here, putting a percentage either side, and then finding the repositories with a name like this. So ClickHouse just has to occur somewhere within the name. It could be a substring somewhere in it. And then we're ordering by the number of stars, getting the top 1,000, and we're using a materialized view here to make this a little bit faster. So if I run this, I should get the top repositories with ClickHouse at the top as it's the most starred. I'm going to actually rename this and call this repos. This is the result, but what I have here is a data frame with just one column called repo name. And I'm going to run this without cache, run this again. Okay. So using this data frame, I can then populate my dropdown. Now, if I change to the input here, so if I change this to Spark, then this would have an impact on the values of this, of all the subsequent connected components. That's like a DAG effectively. And as we change variables, it will impact the variables in the tree and all the connected variables that are impacted, hence making sure our application is dynamic. Let's return that to ClickHouse. Now we're ready to add our drop-down. So we just go to Inputs, drop-down, and we want this to be dynamic. We choose our input, repos, we choose our column, repo name. Let's give this a good name. Just call it repo name. And Hex nicely also names the variable, and this should be populated. So if I select a value here, it will then go into the variable repo name. Again, that's just a single value data frame. And let's add this to our application as well. If we go over to our application, we can actually order our components, just drag them around. Makes sense for those to go together. So now we've done this, we can start adding some statistics. I'm not going to build the full application. We'd be here for an hour, and that's not, although an hour is not a long time, it's too long for this particular demonstration. But we can start building some simple analytics. So the first analytics would maybe we show the number of open issues and also maybe the number of contributors. For this, I'm going to use two SQL queries. Okay, and I just select SQL. This is the first one, which gives me the number of open issues. I'm going to call this issues. Let's run this again to make sure it's in the right variable. So 3216 now open issues. The data is changing in the background. We're constantly updating this. So that's someone's just opened an issue. Let's add another one, which will be the number of contributors. Call this contributors. Spell that. Run that. And we've got 1265 contributors. So if I now want to visualize this, I can go to visualization. I'm going to use two single values. I think these render quite nicely for this. Choose the input. First one, issues, open issues. Maybe we call this open issues. Add another one. You can just do duplicate cell. We'll call this contributors. Okay, and we're done. So let's add these to our application by clicking this button here. And we should probably want to move these next to each other, but we already have a fairly dynamic application. Okay, so some basic statistics. And you could imagine I would add lots of issues here. I probably should add stars and number of PRs and all sorts of other widgets. I should say that I find Markdown components quite useful here, where we can actually template in Markdown values and build quite nice visualizations, or quite nice statistic visualizations. But we'd like probably something a little bit more richer than that. So if we wanted to build something a little bit more rich, maybe we want to show commits over time. And we can use the commit history of the ClickHouse repo here for this particular visualization. And I'm going to plot this as a line chart, as a scatter plot and as a line chart. So if I use, again, SQL, I make my query, and you can see that I'm computing per week the number of commits, but I'm also using a window function to compute a moving average. And we'll call this commits. And you can see I'm using the git commits here. And again, I'm templating by the repo name. So I'm always using the value of this selected drop down here to drive all the other visualizations. And if this changes, all of these visualizations will update. Okay, you can see I've got by week the number of commits and a moving average. To graph that, I simply go to visualizations, chart, choose my commits data frame, and then check my x-axis. Let's make it a scatter plot, and I have my commits. Let's also plot, maybe we call this commits over time, add this to our application, and then add another series, this time a line, and we'll actually plot the moving average. We can see our line, it's not very clear, so we just drop onto style, scroll down, and you can see I've actually loaded in the ClickHouse palette, which I love about Hex is the fact that you just load the palette in once and You can then just use those colors, select our lovely yellow, drop over to our app, and we have a visualization. Now, I think that's just as fast and as easy to build as any visualization tool I've come across. And this is not HEX's main focus, but I've already got something that I could show to my manager in sort of less than 9 minutes. Now let's just do a little bit more, make this a little bit richer. So one of the questions that I think is really tricky to ask, that I would want to know about a repo, is who's changing whose code as a contributor to a repo. Maybe not as somebody who's just coming along and looking at a repo, but as trying to provide value to people that are actually contributing to a repo. We would like to know who's changing whose code. This is actually a relatively straightforward query. We just group by adds and delete authors, but we do need this line changes table, which contains a row for every line change. And then I'm not going to go too much into this. I'm excluding bots, and I'm basically grouping by the previous author and the new author for a line. But if I run this, I call this, it's called the data frame that results from this, deletes and adds. Run this and I should get a list of authors, add authors, a list of the deletion author, and then a count. So this just shows me who's changing the code. To visualize this will visualize well as a heat map. HEX doesn't have a heat map, but it's pretty easy to imitate. I can just do 100% stack bar, have the add one author on the x-axis, aggregate by the delete author, and we have a pretty cool visualization showing who's deleting whose code. So who is deleting Alexi's code? It does appear Nikolai and mainly Curtis J. So Alexi's obviously our CTO. I'm sure he's interested to know who's changing his code frequently. Right, now as a final visualization, I just want to show how we can integrate, how we can exploit Python in notebooks as well to make them even more dynamic. So for an example for this, I'm going to plot the number of stars over time, pretty common for somebody who's managing community, for example. This would be an interesting statistic, even if it's a little bit of a vanity statistic. And for this, I'm looking at the watch events on the GitHub Events, and I'm summing up, doing a cumulative sum by month. So I need a window function for that cumulative sum, otherwise it's a very simple query. You can see this is the number of stars growing over time. Now, maybe we're interested in seeing what would that look like in the future. And for that, that's obviously a very simple data science problem. It's just a simple linear regression that we learn about at university. But this is very, very easily done in HEX. Let's call this data frame stars. So it's 2 columns. Let's just add some Python. Now, I'm not going to type all this out. I'll give you a rough idea of or I'll briefly go through this Python and just describe what it's doing, but I think it should be quite straightforward if I can copy it correctly. Sorry, I'm live. There you go, got it in. Okay, so you can see that I'm basically taking the stars variable here. I'm just going to make sure that this is up to date. I'm taking my stars data frame and I'm extracting the number of stars, and I'm training a linear regression model, splitting my data into test and train, which is always recommended, and then training and fitting to the y. So the y is the number of stars, the x is the actual month, which I'm converting into an epoch, seconds, obviously needed to be an integer for a regression. I'm computing an R-squared score to tell me how good this regression fit is. Then I'm accessing the slope and the intercept, and I'm generating predicted values between these two dates. I've hard-coded this. This could easily, if I could have just accessed stars month and accessed the first column, but I've just hard-coded it from 2020 to 2025, and then I've predicted these values, and then I've merged the result of this data frame back into my stars data frame. So if I run this, and I look at my stars data frame, this is now running. It's populated all of these data frames, all the variables in here. Python variables have been populated and are available now for access in the rest of my notebook. So I've got all of these data, all of these variables accessible. The ones that I'm interested in is basically the result. So that would be this one here, which is a full Python data frame. And you can see it's got 3 columns now: month, stars, and projected. So let's add a visualization. Let's plot this over time, select result. Let's take a quick look at these results here. We can see that we've got projected values as well as star values. And you can see we have up to July for stars, but we don't have, and you can see we are predicting values into the future. So let's plot this. Very simple to plot. Let's go month on the x-axis, stars on the y. I think it makes sense to have this as a line. You can see our stars is pretty much linear. Let's add another series, but rather maybe we add another line. But rather than stars, we make this projected. Go over to our style. Let's make this a little bit easier, or it'll make it clear that it is a projection with a dash line. And we can see now that we can predict the number of stars in the future. So in April 2025, we'll have around 35,000 stars for ClickHouse. I'm going to add that to my application, and I can actually prove that that's a reasonably good projection by just checking the R-squared value. So let's just select the R-squared value from here, and you can see that it's actually 0.99, which is I'm not going to add that to my application, but that's a really good value, so closer to 1. So you can see, build a really simple application. This is more of a data science problem, but it's still quite interesting, and maybe on other repositories they don't have linear growth on the number of stars. We're quite fortunate here at ClickHouse. I'm not going to build anything else, but I will show you the final application. I did build this one. This is the final application that I built. So again, we have statistics here. I've used the markdown widget that I talked about. We have some statistics laid out, the commits over time, the commits by week, the latest commits, stars and PRs. It's interesting. Stars and PRs correlate very tightly. Who are the top contributors over time? This yellow is other, but otherwise we can see some interesting people being added. And then most consecutive days of commit. So Alexi's top there, but Ksenia, one of our developers, is quite close far behind. We can see the contributor type, the activity type, number of open issues, number of closed issues, how long it takes to close issues. So a lot of issues closing within a day, which is great to see. It shows high activity from our support team and from our developers. What are the latest issues over time, and then we can even do a code analysis because we have the actual commits and all the line changes. We can do a code analysis and see how the number of lines is changing over time. We can see the top extensions. We immediately get an idea what the type of project it is. It's a C++ project. Which files have the longest history? Anybody who works or has worked with ClickHouse will know the merge tree is our main table engine. It has a very long history right from the start. And then who's deleting his code, which we talked about. And then finally, repositories. People contributing to this repository. What other projects do they contribute to? Sorry. You can see, obviously, this is the previous name of the repository, but there's some more interesting ones here other than the clients, like the ClickHouse Go client, JDBC client. We can see that people are contributing to StarRocks, Doris, Flink, Incubator Doris, Spark, RocksDB. So we show a lot of contributors with other databases. Okay, that's all I wanted to show. So in summary, I think it's a good case to use HEX. I use it a lot to build an application as a proof of concept, to say, right, I want to go and build this. What would it look like and feel like? It can be interactive. I can then share this with my manager, and I can say, can I go and build this? And hopefully they're supportive. So thanks for watching, and see you next time.
All right, thanks everyone. Thanks Dale for this great demonstration. I think through that we were able to see the power of HEX in action. This app actually that Dale just showed is available for everyone to consult. We published a link in the accompanying blog post. You are able to make a copy or just have a look under the hood, what's happening behind every of this visualization. We also made sure to distribute the code that was used to build this data set. So this is the blog post I was referring to. Feel free to have a look. You'll find some interesting links in there for any resources we've used, but also learning resources. Finally, we've listed here our social handles as well as our Slack community. You can join, ask your questions. You'll find great learning resources on both our websites. I don't know, Matt, if you want to add anything to that.
Yeah, if anybody goes and further explores the GitHub data set or another data set and creates an interactive report like this, we'd love to showcase it on our site or on our social media. You can, with any HEX dashboard, you can publish it to the web. So please let us know if you create something cool. We'd love to share it with more of our community.
Thanks, Matt, and thanks everyone for tuning in today.